Good morning, all. I am Professor Srilata from Sai Vidya Institute of Technology, and I am handling the topic computer organization for computer science students. Okay, today I'm doing the topic interrupts. Right. So, what is an interrupt? An interrupt is an event which stops the execution or continuous execution of an other event. Okay, so something is in the continuous process and somebody comes in between and stops that process, and that is an interrupt. Someone coming in between and stopping, okay, the continuous flow. So the stopping process, that is the interrupt. Now there are two types of interrupt. There is hardware interrupt and software interrupt. So there are two types of interrupt: hardware interrupt and software interrupt. Interrupt which is caused by the hardware uh, devices. Okay, that is like a mouse click, mouse double click, right click, left click, all those are interrupts. So how do you say it is an interrupt? Now suppose a program is under execution, suppose downloading of some images or downloading of some videos or the execution of C program, anything. Okay, so some process, some work is in process, processor is busy doing something. Okay, suddenly you click on an icon which is a file which has to be opened. So it is a mouse click interrupt, a mouse click interrupt, and it has interrupted this downloading and execution process. And now this mouse click has occurred, and this whatever is app or file on which it is clicked has to be opened. Okay, the processor must work on this now. Fine. And this work, so here mouse click occurred, and this is interrupt. Okay, that is an interrupt. It has stopped the execution of the previous process, stopped in between. Okay, and now this file has to be opened, and that is interrupt handling. Okay, interrupt handling. Now this interrupt, whatever has occurred, has to be handled. After the interrupt is handled by using some function, interrupt service routine. Okay, by using some function, you open the file or the particular properties you see, or the keyboard values is taken. Okay, so the interrupt is handled, and after this process is complete, the program, that is the downloading process, continues. Whatever was the program which was executing previously, it continues. Sorry, P1 continues. Okay, that is the downloading process continues. Okay, so this is with respect to mouse click. Similarly, an interrupt can be from keyboard entry of some keys you press, you are trying to enter some data. Okay, it is an interrupt, and that data has to be immediately taken by the processor. Okay, it can be a keyboard interrupt or a monitor interrupt or a printer is interrupting and requesting for some value, some files in between. Okay, or it can be a hard disk which interrupts the flow of execution. So all these are hardware interrupts. Similarly, software interrupt, like there is divide by zero, and all time means like an interrupt, software interrupt, or you're trying to access memory which is out of bound, which is not being able to access by P1 program. Okay, P1 program is not able to access the, is not supposed to access that part of memory, but the program is accessing that memory. Okay, so such interrupts are software interrupts, and these are called as exceptions. Okay, we'll see that later. Now we'll see how an interrupt is handled. Okay, what is an interrupt, the definition, and how it has to be handled. Now coming to the interrupts definition, it is an event which suspends the execution of one program unexpectedly. Okay, unexpectedly, and begins the execution of, and begins the execution, and begins the execution of other program, or it is a system program, any program, fine. So whichever an interrupt has occurred, that program has to be, that interrupt has to be resolved. Okay. So it is a sudden jump from one program to the other program. It is like you're continuously watching, you're watching TV, someone of the channel in TV is being watched. Suddenly your sibling comes and interrupts, okay? They want to see the different channel. So it is an interrupt when you were continuously in a flow, okay, going through that channel, but an interruption has occurred, okay? But here the interrupt has to be served. Fine. Now, we'll see how the interrupt is served. Okay. There is something called as interrupt service routine. Okay, interrupt service routine, in simple words, it is nothing but a function which resolves the interrupts, or which handles the interrupt. I told, when an interrupt occurs, it has to be handled. Okay, the interrupt has to be handled, or the reason for that interrupt has to be solved. Fine. And that is solved by interrupt service routine, in simple terms, ISR. Okay. So how it is solved? How does the sudden jump from the particular location I to, suppose, particular location A1 takes place? This usually works with the help of interrupt vector table. IVT is interrupt vector table, which helps in moving to the interrupt service routine location. Okay, there are many number of interrupts, like in the assembly level language. If I take, there is int 3h, int 13h, int 15h. Okay, all these are different interrupts which causes the stop in the execution of program. Okay, which stops the execution of the program. So whenever an interrupt occurs, immediately the control moves to IVT, interrupt vector table, which consists of two columns having the interrupt number and the corresponding address of interrupt service routine. Okay, so 3h is mapped to a location A1. Fine. So when this interrupt occurs, interrupt vector table tells to go to location A1, and it goes to location A1. The execution of these statements takes place, means the interrupt is handled or the interrupt is resolved. Okay, the control comes back to the next statement which has to be executed. Okay, so that is interrupt vector table and interrupt service routine, a function which is executed to solve the interrupt, okay, or to handle the interrupt. Now, when the sudden jump from the location I to A takes place, okay, so how is it coming back directly to I plus 1? Where is this data stored? I plus 1's location must be stored somewhere. The variable, suppose int A, which is used in the statement, I had assigned it to 50. Now I am trying to use the value of A here. Okay, so this must be stored somewhere. So which are the places? How is it stored? We'll just see about that. Okay, how is this when the swapping is taking place? From the control is moving from location I to A, what A1, what has to happen within the system? We'll see here. So the same diagram, interrupt has occurred at I. Okay, so when the program is under execution, suppose, okay, so at the I minus 1th location, the PC value will have the value I indicates the PC register will have the address of next instruction to be executed. PC is a register in the processor which holds the address of next instruction to be executed. Okay, so when instruction I minus 1 was under execution, the value I is stored in PC. Now the instruction I is started to execute. Okay, so immediately PC value will be incremented by 1 once it it is incremented to the next location of a memory so that it is ready to access the next instruction. Now, when ith instruction was under execution, an interrupt has occurred suddenly. Okay, now this value what is in PC is moved to a stack. I plus 1 is the stack. Okay, means the value of what is present in PC is moved to the stack. Okay, and the stack pointer which was here is pointed to the next location. Stack pointer points to the topmost value where the data can be filled. Okay, so stack pointer has moved to the next location. Okay, this is in the stack, the value is like, suppose this is 98. Okay, this is 97, and the stack grows, okay, like this, 96 and so on. Okay, these are the addresses of values in the stack. Okay, now into the stack, the value I plus 1 is copied, and the stack pointer is decremented by 1. Stack pointer moves to the next location, indicating where the data can be put. Okay, now using the interrupt vector table, the processor comes to know that the interrupt service routine is at address A1. This is at address A1, the starting address of interrupt service routine. Okay, so A1 is copied to the PC register. A1 is copied to the PC register. Okay, A1. Now this instruction executes one by one. The instructions are executed, and finally after the execution of all instructions, the control has to go back to the next statement to be executed. Okay, so where is the next address of next instruction to be executed? It is in stack. Correct, it is in stack. So SP value, that is stack pointer value, is incremented, and it points to the, it is incremented to the next location, so it points here. Okay, and the value I plus 1 is taken out from the from the stack. The value is taken out and moved to the stack pointer. Okay, so from the statement I plus 1, the instruction starts to execute, continues to execute. Fine. Now, this is about the address of next instruction to be executed. Similarly, the variables, okay, all the variables and values must be stored in the within the processor. So P1 is a program. Each program will have something called as process control block, where the values of the program are stored. Okay, all the programs values, that is variable values, are stored, and it is retrieved back when it starts to execute. Okay, so whatever was there in the registers of the processor when the program was under execution, all that is retrieved back, and the program continues to execute. Okay, so that is the how the interrupt service routine, the control jumps to interrupt service routine, and again from interrupt service routine it jumps back to the program. Okay, so interrupt occurs at address 1, routine is executed, that is interrupt service routine must be executed. So the control has to get transferred. Okay, the contents of PC, which is I plus 1, must be copied to a location, must be served, okay, in the stack, and so that it enables the execution to continue from I plus 1th location. Fine. Now, what is the difference between a subroutine or a function call and interrupt service routine? In both the cases, suppose I call a function sum here, it goes to the particular location where some function is defined, executes this function, and control comes back. Okay, what is the difference here is, this is the user defined function which the program needs to complete the process. Okay, so this execution of this function is needed by the program P1 to complete the, to get the output. Okay, to complete that particular process, it is needed, and hence this function is called by the programmer. Okay, whereas in the case of interrupt service routine, so here this is in an assembly level language, you call the sum as call and the function name. Okay, so that it goes to this particular function, whereas interrupt service routine is an error handling, and it is not expected in prior by the programmer. It has suddenly occurred, unexpectedly occurred. Okay, so that is the difference between the interrupt service routine, the calling of interrupt service routine, and the subroutine function. And here the variables and register values are stored, okay, are stored so that it can be retrieved back once the function returns to the main program. Fine. So the main difference in subroutine and interrupt service routine is interrupt subroutine. The normal function subfunction call is, the subfunction is called because the user needs that function to complete the execution of the process. Okay. What is interrupt latency? Now, interrupt latency is, suppose an interrupt has occurred, okay, and then the interrupt service routine starts executing after some time. Okay, suppose interrupt has occurred at the time t1, okay, and the execution starts to execute at, the interrupt service routine starts to execute at t2. Okay, so the time difference between t2 and t1, this is interrupt delay. Okay, interrupt delay or interrupt latency. So the time delay in starting of execution of interrupt service routine. Okay, why the delay is because the processor should check where is the interrupt service routine present, the address. Okay, and so there is a delay. Okay, so this delay is called as interrupt latency. Okay, so next we'll go to the interrupt hardware. Okay, so how is the interrupt information about the interrupt sent to the processor? Fine. So this is the circuit of the hardware devices. So IO devices are connected here. Okay, IO devices are connected here. So all these are connected to IO devices. Okay, you can see that between the IO device and the interrupt request line, this is interrupt request line. Okay, you can see INTR, interrupt request. Fine. So between the IO devices and interrupt request, there is a switch. Okay, there is a switch which is indicated here. So when the switch is closed, okay, when the switch is closed, the current, when the switch is closed, the current, the power passes through the switch, okay, and it is grounded. Okay, now one second. So here you can see the power which is supplied, that is, there is a supply of volts DD. Okay, so that power is supplied. Suppose there is no interrupt request from any of the IO devices. When there is no interrupt request by any of the IO devices, all the switches are open. All the switches are open. No current is grounded. Okay, there is no grounding which is happening. All the switches are open, and the voltage passes as it is to the processor. And here at the end, you can see there is an NOT gate. That means if the voltage I consider as 1, high voltage, okay, then it returns a 0, 0 indicating that there is no interrupt from any of the device. Okay, so it is said to be an inactive in inactive state. Okay, so it is an inactive state. Okay, the whole power is passed to this interrupt service, interrupt request line. Fine. Now, where is the input output device? All the input output devices are connected via the switch. Via the switch, it is connected to the interrupt interrupt request line. This is interrupt request line. Okay, via the switch, the IO devices are connected to the interrupt request line. Okay, so when there is no interrupt, the switch is open, current does not flow here. Okay, the whole voltage moves to the processor. There is a NOT gate at the processor, so the value returned to the processor is 0. There is no interrupt. Whereas when the switch is closed, okay, suppose I have an interrupt from this device. Okay, there is an interrupt from this device. So suppose it is keyboard. Okay, so SIN flag is set to 1 and the keyboard interrupt. Okay, keyboard interrupt request flag in the status flag is set to 1. The switch is closed. When the switch is closed, the current passes through this switch and it is grounded. Okay, so the value which is the power voltage here is 0. Okay, the power voltage which is being sent to the processor is 0 and the INTR line returns after this NOT gate, it returns 1. 1 indicating that an interrupt request has come. Okay, now processor has got an interrupt request. Fine, now the processor has to react, has to check which device has sent this interrupt request. Okay, so this is the hardware setup of interrupt, how the value signals are sent to the processor. Okay, so similarly, if suppose there is a interrupt request from this INTRN, okay, there is a request from this input output device. Again, the switch is closed here. Okay, all the power is grounded. Okay, so there is again 0 from here itself, it is 0. Okay, and finally the value which is passed is 1. Now two devices has sent an interrupt, to the processor. How will the processor know which device has sent the interrupt? Okay, we'll see that in the next topics. Fine. So the switch is open, means no interrupt is sent. Okay. There is no interrupt which is sent in this state. If the switch becomes closed, okay, when the flags are set, the switch gets closed. Okay, and now the voltage is passed through the ground and value 1 is sent to the processor. Okay, so we'll see the next topic in the next video, that is enabling and disabling of interrupts will be the next topic. We'll see that in the next video.